Hi everybody, Grandad here. What am I up to today? Well, today I'm going to look at one or two little bits and pieces that I've got, and I was going to show you one by books. Now, books have always been an interest of mine, even though I'm not a very good reader. And this book in particular is called The Pictorial Knowledge, and it's probably 80 or 90 years old, this book, when it was first published. And when I was a child, I was a bit of a sickly child, and I was always ill all the time and spent a lot of time in bed with various chest complaints, colds and what have you. And so sitting there in bed, sort of convalescing, I would look at books very much like this, and they contained scientific bits and pieces. And this particular volume, there's 6, I think there's 12 books in the actual volume of book. It's actually an encyclopedia. Now, it's a pity that they don't. There's an encyclopedia which is very good, which is called the Encyclopedia Britannica, and I've got a copy of the Children's Encyclopedia Britannica because that particular book was very expensive, and to buy the set of books, and I couldn't afford it. But I got the children's one to help my children with their education when they were younger, and they're very good. And I'm disappointed that the Encyclopedia Britannica is no longer printed. It's all online, I think. You can get it on the internet, but it's not the same as looking at a book. And as I said, as a child, I used to look through the pictures in this book. It's called The Pictorial Knowledge, and most of it is in pictures. Now, although it's very old-fashioned now, it covers a lot of subjects which greatly interested me. Things like magnetism and electricity and metals and geology and science in general. And I got really hooked up on it. And one particular thing I got interested in was electricity, or at least a certain kind of electricity, called static electricity. Now, static electricity, as you may know, occurs when you rub surfaces together. A balloon or something, if you rub it on your jumper, it'll stick onto a wall, and that's held there by static electricity. And as this book shows you, if you rub a rod, shows you a picture there of someone rubbing a rod, and if you rub a rod with little bits of paper underneath, it will be attracted, like a magnet almost, to the rod. Now, it's not magnetism, and the same with this here. There's a piece of glass has been rubbed, and the little bits of paper underneath are jumping about. Now, that is not magnetism. It's actually electricity. So it's interesting because it's an energy which is invisible. You can't see it, but you know it's there because you can prove it by different experiments. And one of the things in this book which intrigued me when I was a child, and I always wanted to try and make one. In fact, I did try and make one, but they're so difficult to make I was unable to. I did make it, but it didn't work, unfortunately. There was parts missing or not in the right place. I'm not quite sure. I didn't have the right materials, and it didn't work. But it's this one, and it's called, there's a picture of it there, it's called a Wimshurst machine. And it was invented in about 1800s, 1880 I think, by James Wimshurst, and it's a static electric machine, or static electric pump, or an electron pump as some people call it. And what it does, it actually produces a current, and it stores it in these things that they call linear jars, or Leyden jars. There's a close-up of a Leyden jar there, and it shows you how the Leyden jar works. And what it does, it steals electrons from one of these jars. There's 2 jars involved, and it steals electrons from one jar and stores it in another jar. And when you bring these 2 arms together, it shows you on the picture, the actual discharge of electricity or static electricity is shown by sparks and a loud noise. So that got me interested in Wimshurst machines, and I've always been fascinated by them ever since. But of course, it also brings you on to what I was talking about before, which was invisible energy. Now, there's several ways you can show invisible energy. There's lots of different kinds of energy, and one of the ones that interested me was this little gadget, which I'll bring over now. Now I've got a light here. Now this little thing is called a what's it called? I can never remember the names when I want to. It's a something-ometer, radiometer is called. And this actually works on sunlight, the energy from the sun. Now obviously in this room I've not got a lot of sun, but I have got a light here and it's not very powerful, so this thing won't work terribly well. But what you've got here is a globe, and inside there's a little windmill that spins around. It spins around when you knock it. But when you shine a light on it, something rather curious happens. I'll put the light on now. I'll try and shine it away so you can see what's happening without being blinded. But the light actually makes, a little bit further round so you can see it, the light actually makes the little windmill inside go round and round. Now I was fascinated by that, because obviously there's no electricity involved, there's no wind involved to blow the little sails round. It's just the energy given off by this light bulb pushing against that silver and black side of that little windmill, causing it to turn. And in the sun it really spins really fast, but obviously I haven't got the sun here. But this light is powerful enough to radiate enough energy to push that little windmill round. Now I find that really interesting, and it's called a radiometer. Now another thing that I wanted to talk about was the weather, which is strange, but I wanted to talk about the weather and about a gentleman who actually invented weather forecasting. And some time ago I made a video about Charles Darwin when he sailed on the Beagle, and to do his circumnavigation of the world, and he went on to accompany the captain of the ship, which was called Fitzroy, Captain Fitzroy, or Admiral Fitzroy as he turned out to be. Now Captain Fitzroy had a fascinating life. I mean, he was a sailor. He went into the Navy when he was about 12 years old and sailed on his first ship when he was about 14, and he worked his way up through the ranks until eventually he became a captain. And he'd had a couple of voyages on the Beagle before he went with Charles Darwin, and he's got quite an interesting history. I won't go into it here, but if you look up on the internet all about Captain Fitzroy and the things he invented and the things he used during his time, it's very interesting. I mean, it was sad that he came to a very sticky end, unfortunately. When he got into later life, he got into debt and he got into ill health, and he suffered a lot with depression, and very sadly at the age of about 60, I believe, he actually committed suicide. And so he came to a very sticky end. But during his life he did do a lot to help people with the weather, because he was convinced that sailors and people at sea needed to know about the weather. So he really invented what they call now weather forecasting, and that's something that he had a lot to do with. Now something that I don't know whether he actually invented it, but certainly he used it, and it's this little device, and it's very interesting. I find it interesting, and it's a sort of a weather forecasting machine. And it's called a weather in a bottle. But what you've got there, and I've got a small torch here because I didn't want to put that big light on, but if you look here, you've got chemicals inside this cylinder, and it's got a little bit cloudy at the top there, a bit dirty, but there's certain chemicals inside here, different things, potassium, nitrate and alum, and I can't remember, there's camphor I think is in there, and alcohol, distilled water, and various things mixed together to produce these crystals. Now, as you know, I'm very interested in crystals, so this fascinated me. But what happens is, as the barometric pressure changes, because that's to do with weather forecasting, the barometric pressure, the air pressure changes, it alters the shape of these crystals and makes this liquid behave in different ways. And by studying each day the way these crystals are forming and deforming, you can tell what the weather's going to be. If you look at what's happening in here and then make a note of what the weather was doing at that time or 12 hours before, you can see you can tell what the weather was going to do. And now this was a great help when you had no weather forecasting sort of methods years ago. This was quite an innovation. But the reason I'm fascinated by it is because if you look inside, you can see these fascinating tree shapes of crystals. I'm hoping you can see them on camera. I don't know whether you can. I'm hoping you can. But if you can't, I'm sorry, but I'll just have to take my word for it. But inside there's lots of different shapes of crystals. They look like trees, little fir trees and things. And that's it's quite fascinating to watch that as the crystals change and form different crystals to decide on the weather. Now, we know that barometric pressure is to do with weather forecasting, and another little gadget I've got here that I thought I'd just show is this one, which is another weather forecasting piece of equipment, and it's quite interesting. It's beautifully made piece of equipment. It consists of a wooden board, and there's a glass, beautifully blown glass instrument here. And you fill it with coloured liquid. There's liquid in the bottom here. This one's got a little bit empty. And what happens is when the temperature, the barometric pressure changes, it alters the pressure inside this cylinder and presses up on the spout here. And this liquid will actually move up and down this cylinder. This little tube here will move up. And in fact, if it gets very high, the pressure gets very high, it'll actually come up and overflow out of the top and run down into this little cup at the bottom. And if you can see, I don't know whether you can see, but there's blue material in here where this thing has risen so high that it's pushed the liquid out to the top. And that's all done by pressure of air pressure. And the difference in air pressure gives you, when there's low pressure, you're going to get different weather than when there's high pressure. And at the top there's another couple of, it's called a conforming monitor or something. Conforming monitor? Conforming monitor. But it's also got a temperature gauge and a humidity gauge at the top there as well. And it's quite an interesting little bit of scientific equipment which I thought I'd just show. For using an invisible force, which you can't really see, which is the change in pressure. We don't notice the change in pressure, but the change in pressure is happening all the time. And by doing that you can forecast the weather, which is how Captain Fitzroy did it. Now, I started this video off with a look in my book, and one of the things that I showed in there was the Wimshurst machine. So I have actually acquired myself a Wimshurst machine. I bought it and I've got it here, and it's quite a large piece of equipment. Now, it's come all the way from China, and it wasn't terribly expensive. I mean, I was quite pleased with how much it cost. Probably more than I should have spent, but there it is. It's a Wimshurst machine, and what it consists of is these two cylinders on either side, which are the Leyden jars, and they hold all the whether it shows up any better with light on it, I don't know whether it does. Put a little bit more light, I'll try it. Considers of these two cylinders. Put my light up on the top. Maybe it'll show it better there. Put the light up there. These two cylinders, which are the Leyden jars, and these two rods, which move further and nearer and further apart. Let's shape that down a little bit. And at the back there are two discs. And this little handle on the back here, when you turn it, these discs revolve in opposite directions. They've got one of the pulleys is crossed over, so it revolves the opposite way. And it's got a couple of pickup points and some little brushes, which brush against these little bits of foil that have been stuck on the discs. Now, when you wind this handle round, there's nothing actually touching. I mean, the brushes just rub against the side of the machine, but they're connected together, and they're not actually touching any of these other metal parts. And these little parts here at the sides, they're not actually touching the glass wheels here. So nothing's actually touching. So there must be some invisible force going on here. There's something invisible that you can't see, but something's happening. Now if I move these arms just about that far apart and wind the handle, we should see what happens. I'll start off revolving, and at a point when the charge in these jars reaches a critical point, I'm hoping you can see that. Hope you can see it and hear it. A spark occurs at the end of those rods. I'll just try and zoom in a little bit. See if I can zoom that in a little bit to the end of the rods. Get them full in camera. And I'll try it again. As I say, when I revolve it, it gets to a point. Let's turn this light out now. Maybe that's too much light. Put it in the dark a little bit. There we go. Now, I hope you can see that, but there's a really big discharge of electricity, or static electricity, occurring between those 2 points. And it's quite powerful. Now, although it looks like a spark just jumping across the gap, what's actually happening there is and if I bring them close together again, get a little spark at the end. But what's happening is the charge inside these linear jars is building up, and what happens is when it discharges, it tries to balance itself. So all the electrons out of one, the negative electrons that are stored in the one, rush over to join the electrons in the other one, and vice versa. They try to join it up to equalize the force and therefore bring everything back into equilibrium. But because when it shoots across, it actually overcharges the other way again, and so it bounces back the other way. So what you're actually seeing there, although it happens in a split second and you're seeing just one spark and one bang, what's actually happening is that spark is jumping back and two so fast that you can't see it, and it looks like just one spark, but in actual fact it's a lot of current going back and two, back and two, back and two to make up the charge. Now this is quite a wonderful little gadget, and I've wanted one all my life, and it's taken 70 odd years to actually get one. So I'm very pleased that it arrived all the way from China. It was a little bit damaged in the post, but you can understand that, but it works all right, and therefore I'm quite pleased with it. So that's my little Wimshurst machine, and I'll go on playing with it. I'll try it in the dark tonight when it's really dark. I'll try it, and hopefully this spark will look even better. So I'll just wind around a little bit now and leave you with the sparks, and I'll say this is Grandad saying bye until next time when I find something else to show you. Bye bye now.